Hi everyone. So in this video we're going to discuss how to graph an equation given our first derivative, second derivative, intervals of increasing, decreasing, vertical asymptotes, relative max, concavity, pretty much everything you can find in respect to calculus. So let's say this chart was given to you and they were telling you that it was increasing from this interval, decreasing, and etc. The first thing you actually want to do before you graph it, given an equation, is first thing about what type of equation is it? Well, you'll notice that since I have x squared minus 9 over x squared minus 16, that's a rational equation. And with rationals, you have VAs and HAs, vertical asymptotes and horizontal asymptotes. So the first step is always find your VAs and your HAs. Well, you find your VAs by setting the bottom equal to 0. X squared minus 16 equals to 0. Solving it, and you're going to get x squared equals to 16, and x equals to plus or minus 4. So that means that my vertical asymptotes are going to be x equals plus or minus 4. Now I'm also going to find my HAs. I find my HAs by looking at my degrees. Well, I notice that my degrees from top and bottom are both 2. So when the degrees from top and bottom are both 2, I'm going to divide the leading coefficients. So 1 over 1, and that's going to give me a horizontal asymptote at y equals to 1. I find this stuff out because I want to be able to understand what type of graph I'm going to be dealing with before I actually go ahead and find my characteristics of my first and second derivative. Now once you find that, normally in calculus what we do first is we find our first derivative. So what we're going to look at in this example is we're going to only look at our first derivative, because our first derivative is going to tell us everything. Now our goal is you're looking for two things. You're looking for when you have a critical number, and that's when f prime is equal to 0, and when you have an undefined point, because critical numbers are undefined and also values that give us 0. So what you're looking for, undefined and 0. At these values, you're going to graph that on your number line. Because remember whenever we're testing increasing, decreasing, we put numbers on a number line and then test values between them? Same thing here. Undefined happens at -4. Now why should I get an undefined value at -4, get a real value at 0, and get another undefined point at 4? So why are -4 and 4 undefined values? The reason is, remember, these are the same values you get for your vertical asymptote, so you're never going to have a real point. So anytime you get an undefined point, it's also a critical number, because you have to see the difference what's happening from the left and the right. So the numbers you're going to put on your number line are undefined points and zeros, which are all critical numbers. Now your next step is determine what's happening from this interval. What's happening from -3 to -4? But what I want you to do is only focus on this portion of the graph, the first derivative. Well, left of the -4 is -3 to -4, which is positive. Remember, positive means it's increasing from -4. Also positive, increasing from 0 to 4, negative, decreasing, and then from 4 to infinity, decreasing, negative. Now how do I know it's decreasing when I see a negative, or positive when I see increasing? Remember, when you actually test for an interval, all you care about is if it's a positive or negative value, because positive means increasing, negative means decreasing. Positive slope, negative slope. Now, once you find your intervals of increasing and decreasing, you're told that you want to be able to find any max or mins. Well, in order to have a max or min, you have to have an increasing to decreasing interval, or decreasing to increasing. Well, if you notice, there's a max at x equals 0. Well, 0 comma what? 0 comma, remember, we always have to plug this into our original function, but not when a table like this is given to us, because this is our y points. So you're going to look at 0 and see 9/16, meaning 9 over 16 is our y-intercept for x equaling 0. Alright, so this is where our max is going to occur, because it's increasing and then decreasing. So once you find your intervals of increasing, decreasing, and max mins determined by the y prime, you're going to focus on y double prime, your second derivative. Now to find your second derivative, what we're going to look at is the portion where it deals with the second derivative. And the second derivative is the same exact thing and the same exact process as the first derivative. What you're trying to find is your undefined points and the values that give you a critical number, which you're going to notice as 0. So I noticed that I have 2 undefined points at -4 and 4, which of course, because those are your vertical asymptotes. And do we have any other critical numbers values that give you 0? Like we had in y prime? You don't get anything. But you do get -7/128. But what does that mean? Why do they give us -7/128? The reason they give it to us is because left of it is a critical number. So they don't want to just leave this a blank spot. So whenever you see a critical number and a number like this that's next to it for under y prime or y double prime, don't pay any attention to it. What you want to actually pay attention to is the sign in front of it, which is a negative. Meaning that at x equals 0 for y double prime, it's concave down because it's negative. So anytime you see a number like this, don't pay any attention to it. So what you can do now is test your intervals. What's happening from -3 into -4? Well, look higher than this undefined point x equals -4, it's positive. Well, what does positive mean with second derivative? Concave up. Then -4 to 4, negative, 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 meaning they're all going to be concave down. And then from 4 to infinity, positive, so concave up. Then you can ask yourself, well, after you do your concavity test, are there any point of inflections? POI. Well, point of inflections occur when one interval is concave up to concave down to concave up. Well, this is concave up to concave down, but what's at -4? -4 and +4 are VA, so technically there are never going to be any points at -4 and 4, meaning no point of inflection. There will never be a point of inflection at a vertical asymptote. Now, once you have this, that's all the information you actually need to be able to graph this. So what we're going to do now is we're going to go ahead and actually graph this. So when we actually graph this, I'm going to put this sheet side by side with all of the information that we actually found. Now you'll notice that I actually don't need my chart anymore. So when I graph this, what I'm going to first do is I'm going to first graph all my VAs. Well, I have a VA at -4, and I have a VA at +4. Now what was something else we found in the beginning? We found our HA because that HA is at y equals to 1. And then you want to graph any maxes. Well, there's a max at 0, 0,9/16, which is somewhere between 0 and 1, so you know you have a value right here. Now what else could possibly help me figure out my graph? X and Y intercepts. So whenever you have to find an x-intercept, you're going to set the top of your equation equal to 0 when it's irrational only, and solve it, you get x is equal to ±3. So that means at -3 you have an x-intercept, and at +3 you have an x-intercept. And then we don't have our y-intercepts already found for us, which was happened to be our max, okay? So that's why we don't have to find our y-intercepts. Now once you have this, we don't have any other information. So what we have to do is we have to graph everything that was given to us. Look at y prime. These intervals you want to create. So what you want to do is you want to actually create those intervals from -4 to 0. So -4, 0, and 4. You're breaking up your graph into boundaries just like you did for y prime. So -3 to -4 is increasing, but the problem is I don't really know which one it's increasing to. So I'm going to put it up here and down here because I don't have any points. I have no idea where it's increasing. Is it increasing up here? Is it increasing down here? No idea. What about -4 to 0? Well, maybe it's increasing over here, but as you notice, you have points already over here. So if it's going to be increasing, it has to pass through these points because your graph is continuous. So I know it's going to be increasing here. What about 0 to 4? It's decreasing. So I know my graph has to go here to here because I'm just playing connected dots. And then what about 4 to infinity? It says it's decreasing. 4 to infinity decreasing, so I don't really know where it's decreasing to because I don't have any points, so I'm going to graph them like this. Now, once you finish increasing, decreasing, and you graph your max or your min, you're now going to move to y double prime. Well, y double prime is telling me from -infinity to -4 it's concave up. Well, how does concave up look like? Where should it go? Since it's a rational graph, I know I'm going to have a graph like this or like this. But which one is concave up? Which one matches concave up and increasing? If you notice, this is concave up and it's also increasing from this point to this point, but this is concave down. So this cannot be my graph. Now, a shortcut to memorize rational graphs whenever you have to do concave up or concave down, concave up literally is above the graph. Concave down is below the graph. So that's why my graph is up here. Now let's look at -4 to 4. From -4 to 4, it's telling me it's concave down. Well, that makes sense because this will create a parabola in the middle. And then lastly, from 4 to infinity is concave up. Remember, concave up is on top. So you know that your graph looks like this. So if you were to redraw this graph, your graph is going to end up being vertical asymptotes at -4, +4, y equals to 1 is your horizontal asymptote, x-intercept at -3, y-intercept, which is also your max, and another x-intercept. You have a downwards parabola. Since it's concave up, you know your graph is up here and up here, and this is your rough estimate of your graph. And this is what our graph will look like. So all we did was we found everything that this chart that was given to us. We looked at y prime, we looked at y double prime, and graphed on a number line everything that it was telling us to do. We then found max, mins, possible point of inflections, graphed everything, and used what was given to us to find our answer. Alright, so hopefully this video helped, and thanks for watching.